Hello everyone. Our project is titled The Comparative Analysis of Classification Algorithms for Student Performance. So in this project we shall look into some of the various classification algorithms which are there in the educational arena in today's world, and we are going to analyze their accuracy and results. So basically what we'll be doing is we'll have our training data sets which are raw Excel files from our college database, so which looks something like this, and we are going to use this to train our classifier, and then we will be predicting results for the test sets which will look something like this. So in the test set the result column would be empty and we would be predicting the results based on the machine learning from the training set. So the first step in this would be to clean both the test and both the training and the test sets, and then convert it into an ARFF file format. And ARFF file format stands for Attribute Relationship File Format. So ARFF file looks somewhat like this. So it looks somewhat like this. This is the name of the relation. These are the different attributes, and this is the data. So this is similar to a CSV type file, and we are converting this our data sets into ARFF files because for the classification we are using a tool called Weka, and Weka only accepts input in ARFF format. So we are going to use something called Google Open Refine to clean and process our raw data sets and convert them into an appropriate CSV file format, from which we'll later convert it into the ARFF file format. So let us open Refine. So Open Refine is made to run on a browser. So if we point to this IP address, it will Open Refine. So as you can see, this is Open Refine. So we create a new project and we choose the file. So we choose the training raw data set, and the data is uploading. So these are the different attributes. So we start the project, and I shall demonstrate a few pre-processing steps. So okay, the first thing, Weka does not accept any spaces in between strings. So we can use something called transformation for cells, and we could write a small code snippet to remove all the white spaces. For example, value dot split wherever it encounters a space dot join. So as you can see, all the spaces will be removed and there won't be any spaces between strings. So if we do this, we can see that 192 cells have been modified. So basically the whole data sheet has been modified. Similarly, we could do something like clustering. For example, we have three kinds of boards: CBSE, ICSE and state. So instead of these various boards like PU board, Karnataka board, board of PU education, Karnataka, etc., we can cluster the similar boards into a same type. For example, let's have a text facet. So as you can see, there are a lot of different 68 choices, and we would want ideally 3. So for example, if we cluster, for example, this, we could cluster all these rows into something called as, into a particular, for example, this. So if we merge selected, so now we have something called state, which should have the all the rows which we previously clustered. In the same way, we could do something for numerics. For example, someone there is an empty row, or there's a alphabet in the numeric column, so we can give a numeric facet, and we can see that there's one non-numeric value. So if we want to see only the non-numeric value, we can see we can see a row in which there are a lot of empty columns, or it's not matching, the data is inconsistent. So in this way, we use OpenRefine to clean the whole data set, and after that we save it in a CSV type file format, and after which we convert it into an ARFF file format. So we have already done that, and this is the training ARFF .ARFF, and this is the test.ARFF. So now I shall run Weka and show you how it actually works. So this is the Weka application. So we are going to use the Explorer of Weka. So initially we open the file, so first we open the training set. Now these are the various attributes. Now we shall remove the attributes which are unique and will not affect the machine learning in any way. For example, the USN is unique and will not help in the prediction of the result, and so is the name. So we shall remove these two fields. Then we have left with the different attributes which pertain to our analysis. So now we classify using an algorithm, for example the Naive-Bayes algorithm. So first we run it for the training set. So as we can see, these are the various classifier outputs. For example, the number of correctly classified instances, or the percentage of correctly classified instances, the incorrectly classified instances, etc., etc. This is the confusion matrix in which the rows stand for actual pass and actual fail, and the columns are the predicted pass and predicted fail. So after we run it for the training set, we supply the test set on which we have to predict the results. And we run it for the test set. After which we do a cross validation with 10 folds and run it again. And at the end we do a percentage split by 66% and run it for the last time. So in after running for each of the different tests, we note down all these different values, and we later use the values after running for all the three different algorithms. We use the values for our analysis. So let me show you how the result, which was previously empty, for example this was the raw data set in which the result column is completely empty, or I shall show you and here as you can see, this is the result column which has been left with a question mark. So this is the test, so the results have been left empty. So after I show you the results, it would be either pass or fail. So we visualize the classifier errors and we save it. We save it in, we create a new file called as suppose result.arff. So if we open result.arff, we can see that the algorithm has predicted different results. For example, pass, and some students will also fail. So For example, this guy has failed, this guy has failed, and so on. So in the similar way, we do it for we use the same process and note down the various results for all the three algorithms.